Hello, and I hope all of you are well today, and I hope you enjoy my presentation. My name is Douglas William Lipp, and I'm the author of a book, I Have Become Space, 13 Quantum and 12 Cosmological Interpretations Awakened by a Novel Theory of Nature. And today I'm going to try to explain that novel theory of nature. The foreword is by a good friend of mine and physics teacher, Edward Arikian. My other book is Northeast of the Lobster Pot. You can find both books online in case you wish to purchase them. Just Google Northeast of the Lobster Pot or I Have Become Space. This book attempts to teach children the stock market in a whimsical journey on an enchanted island. I'm going to leave this here, but today we're going to talk about the theory. Just a little forewarning, I am not a physicist, I am not a cosmologist, my education is minimal, I won't be using math, I don't understand math, I try to work with concepts. I don't work with, say, Schrodinger's wave function equation or Einstein's field equation. We are going to discuss those in a conceptual way. For instance, Einstein's field equation has matter and energy on one side and space-time curvature on the other. But it looks at them as a proportionality. It looks at a concept where space-time curvature tells matter how to move, and matter tells space-time how to curve. So we're going to be getting into that a little bit, but I just want to give you my presentation. Part one is going to be the quantum classical world. The book, I Have Become Space. And I'll spoil it now. The reason for the title is I have taken the physical world and I have found an equivalency to a volumetric space. So literally, there's a quantification in the book. I do have the quantification. We'll be showing it here later on. But we won't show how I derived it, for lack of a better word. That's in the book, in case you are interested. So what we're going to do is try to attempt to discuss everything on this board. If I flounder or misrepresent something or misrepresent physics entirely, just so be it. That's the way it's going to be. Because I'm not a physicist. But I do have my theory, and I know my theory, and I enjoy my theory. I've spent a lot of time thinking about it, thinking about the problems, and coming up with at least my solutions to the problems I've read about. If you leave this presentation, try to remember one thing, that CIG theory here, CIG theory, the acronym for the Coney Island green theory, CIG being the search for a hidden variable. And that search may be over with CIG theory, but that's up for the community to decide. It may be delusional on my part, but I try. And I enjoy it. I'm very happy with my theory. CIG theory reinterprets matter as the curvature of space-time. That's what it does. And there's an equivalency. And if we take this interpretation, you'll find it solves so many things that we're going to talk about. The old definition is that which has mass and occupies space. We learned that in grade school. That which has mass and occupies space. My logic tells me that matter could occupy matter and have nothing further to do with space. But as soon as matter occupies space, It's by default a manifestation of space. And when we talk about space, we use the general definition as that extensional volume in which things happen or occur. It's the V in the ideal gas law, PV equals nRT, the volume. The space is the volume, and that's how I learned it. Hopefully that's how you learned it. That's the old definition. The new definition, per CIG theory, is matter is that which has mass, consists of the curvature of space-time, and has an element of motion. So we'll see that any particle-like object, say the Standard Model or any object we're used to in our surroundings, has so much potential volumetric space within it. And we're going to back into, and I don't think I have it on the board, and I'm going to put it on the board for later. We're going to put 17 on here. And maybe I do, but we're going to put E equals mc squared, and we're now later going to reinterpret what that E is. So let's begin. And I do hope some of you have a background in these topics, because I'm not going to explain the topics in great detail. This is just an introduction to CIG theory. I would suggest, obviously, that you get the book, learn the topics. You don't have to be an expert in them, but you have to be aware of them. So I may gloss over the topics to, one, pique your interest, or two, go out to that community that actually knows these topics and is very familiar with them, works with them on a day-to-day basis, in which case they'll understand to a greater degree what I'm trying to say. So we are going to mention things like the double slit. If you don't know the double slit, just Google it, go on YouTube, try to learn it. Okay, the double slit came from, and I didn't finish his name here, Thomas Young. Thomas Young, trying to attempt to discern whether Newton was right or whether Christian Huygens was right. Newton said light was a particle, Huygens said it was a wave. So they came up with this experiment where they put light through two slits and they found an interference pattern. Now, there's a problem with this because, and you'll see if you watch your YouTubes, if you throw a tennis ball, it's going to make one line right here. It's either going to go through this slit or this slit. There's no interference with a classical object, such as my drink here. A classical object versus a quantum object. So the idea of quantum came from something called the ultraviolet catastrophe. If you want to look that up, black body radiation and the ultraviolet catastrophe, and Max Planck coming up with Planck's constant. And that basically said there is not a continuous jump in the electromagnetic spectrum with different frequencies and the Bohr orbitals. But what we have here is a classical particle now creating an interference pattern on the back wall. So how does SIG theory interpret and solve that? Well, what SIG theory says is I have this particle, and it could be an electron, could be a photon, and as it travels, the volume actually gets greater. So that particle is no longer the particle. That particle is a new volume. It's a new volume, so part of it can go through one slit, part of it can go through the other slit, and you can get constructive and destructive interference on the screen. So the particle actually gets bigger. And what does that do? Well, it solves the measurement problem, is what it does. The measurement problem is, it's a problem that the measurement, whether it's a consciousness or an actual measurement or something, does something to the wave function to collapse the wave function, but nobody knows what it does. Well, what I've done is, and I'll jump ahead to number 7 here. I have MTS. MTS is the main equation in SIG theory. The T is forward reverse vector time. T this T represents 0 miles per hour all the way to c, which is the speed of light. So t is a vector quantity where this side is 0 and this side is the speed of light. So what does that say? That says that the screen, back on our measurement problem, stops the particle. It reverts back to 0 miles per hour and turns back into its matter particle, as opposed to it being spatial. And that's why here you see particles. Now, you get this interference pattern even if you're sending one electron through the double slit, one at a time. So that brings a lot of confusion to the scientific community, because one electron at a time is still getting you the constructive and destructive interference pattern. If we approach it from the MTS equation, that one electron again becomes spatial. And it interferes with itself to create the pattern on the back wall, which stopped the electron again, brought it back to its particle-like state, and it's no longer in its spatial state. So what we've done, we've reinterpreted matter as the curvature of space-time. We've looked at the double slit. We've solved the measurement problem by saying the measurement, whenever you measure something, you have to stop it in its tracks. You're not measuring it at the speed of light. You're taking one frame at a time. You are stopping that process. And that's the measurement problem. So when you stop it somewhere within this equation to find the particle. Now, we'll look further at this and we'll see that this side of the equation at pure C is going to be the 0-point energy, or the vacuum of space. And on this side is going to be a black hole. And in between, we're going to find everything. We're going to find from a black hole to the Standard Model, to dark matter, to dark energy, to the darkest, for lack of another word, the darkest of dark energy, or the vacuum of pure space. So we're going to move on from here. CIG theory also interprets Bohr orbital jumps, the great Niels Bohr, as new volumes of space that weren't there before. When I learned Bohr orbital jumps, I learned it as it jumped from orbit to orbit with nothing in between, which confused me. But I'm saying that the Bohr orbital jumps now represent new space that wasn't there before. Now, it could also be jumps that change the space-time curvature density in an existing volume or in a new volume. Because remember, matter now and space are now combined as one entity. And later on, we're going to look at that as a solution for quantum gravity. So that's my take on Bohr orbital jumps. Also offers a solution to quantum tunneling. If you're not familiar with quantum tunneling is that situation where a classical particle crosses a classical barrier, or situations where something, say, might walk through a wall. And my take on that is that the element of space in the MTS equation, I'm going to put this big letters here, MTS. As that particle crosses the classical barrier that it shouldn't, what I'm saying that it turns spatial, and spatially enough so it crosses the classical barrier. And classical is this. In my equation, quantum and classical differ by rate of motion. The only pure classical object is a black hole. Any motion creates a frothing of space-time volumes, of curvatures with lesser densities than this side of the equation here. So the new volume or density of a moving particle becomes spatially enough to cross the classical barrier. And that's my solution to quantum tunneling. If you don't know the word, look it up, Google it, learn it. If you're a particle physicist, hopefully this becomes a little interesting and you give it at least an attempt before you dismiss it outright. This process here, what happens between here and here, is so confusing to the scientific community that they've come up, they don't know where the particle is, they try to figure it out via probabilities, and they have a wave function of that superposition. Where is the particle? And what I'm saying is the particle is no longer the particle is now this great volume. this great volume that you see here on the S side of the equation. So in CIG theory, there's an actual decoherence of the wave function. It's not a probability, and it's not on the board here. I touch the topic just briefly here, and again, I probably don't know it very well, but the Heisenberg uncertainty equation says that the more you know the position, the less you know the momentum. The more you know the momentum, the less you know the position. What I'm saying is that the position is no longer a single position. The position now has a much greater spatial extent. So that's how I am approaching the Heisenberg uncertainty principle. CIG theory might lend itself to a certainty principle, where if you know these parameters, you might know where and what volume that particle has become. I'm going to go to 9, and I touched on this for a minute. It offers a solution to quantum gravity. Quantum as m, the m side of the equation, and that constitutes the quantum and the classical world. Right now, they're having a hard time discerning what differentiates the quantum and the classical world. In Bohr's correspondence principle, it's looked at that the classical world is large and the quantum world is small. But CIG theory looks at it that the classical world is slow and the quantum world is fast. So quantum gravity, we have the quantum and classical constituents of quantum, and gravity, per general relativity, the curvature of space-time, as S. In the equation, we have both the quantum classical world. Actually, the classical world is M, strictly by itself, a black hole, no motion, nothing. As soon as there's motion, it turns into the quantum world. And at a certain point, anything really above 0 miles per hour, it has its spatial quantity. So you have a singularity here and a singularity here. So again, that's 0 and that's C, and it goes back and forth. Forward reverse vector time, because remember, time and motion, I believe it's per special relativity, are very interrelated. So that's my offered solution to quantum gravity. CIG theory, the idea of conservation of energy. It is consistent in CIG theory. Probably in the cosmological section, I'll touch base on this a little more. Right now, you have an expanding universe. You've heard of an accelerating universe. And the current philosophy is those spatial quantities keep growing and growing from themselves, from the space themselves. And since there is a constituent energy to space, you're getting more and more energy from itself, which contradicts the law of conservation of energy. Well, in CIG theory, the space does come, but it comes from the matter. So conservation of energy is consistent in CIG theory. I'm not going to go into the math now, but the equivalency is 0.02762 atomic mass units, that being 1/12 of the weight of the carbon nucleus, is equal to 25.7 mega electron volts. And here is what CIG found. In the book, CIG found an equivalency at whatever speed the fusion process was taking place to 14,952,942.08 picometers cubed of space. Whether that's right or wrong, I'm not sure, or even remotely if the theory's right or wrong. But that's my attempt, and I have called this the CUPY in my book. You can read the book if you're interested further in that. Okay, number 12. I've heard of string theory. You've probably heard of string theory. It's an attempt at trying to solve quantum gravity and everything else. And I've heard of them talking about 11 dimensions, the extra dimensions. I started thinking about it in the context of my equation and what's going on. And what I've done here is I've taken the 4 dimensions we're living in now, the 3 of volume, 1 of time, and as you're getting an increasing spatial volume, you get another 3 dimensions, and then finally where it ends up, at an even greater volume, you get another 3 dimensions and 1 more of time. So we're going from order to disorder, entropy, and this adds up to this magical number 11. And I'm just thinking along these lines, perhaps there's some tie-in with the 11 dimensions I hear about in string theory. Brownian motion, which I've thought about. And this is not in the book, by the way, 12 and 13. They're just some things I was thinking about recently. If you're interested, I Have Become Space. This is a good book too, Northeast of the Lobster Pot. Okay, Brownian motion. We've learned this in school, and that's that the pollen is bouncing around on this medium of, I think it was oil, maybe. And what I'm thinking here is that the bouncing may be due to the volumetric changes of the medium at the surface level. We know there's motion, and that's why the pollen jumps around. But if we look at it a little closer, there might be an element of CIG at play, where the medium, due to the temperature, the volume keeps expanding, contracting, expanding, contracting, and that's why the pollen jumps. Going to have a quick check of time here. I think we're doing quite well. Hopefully you're having a good day. We're up to number 14. Number 14 is a conceptual picture that you have the particle here. And as it moves, it's leaving space behind, and it pulls out the curvature of space-time. So the particle is very tight. It's a very tight curvature. The motion will create that space. 15, I think I touched base on this. I did it, we'll briefly read it again. CIG theory redefines Bohr's correspondence principle not as large and small, but as slow and fast. 16. Well, first I'll cover 16 first, and then 17. I've had, and maybe someone out there can leave a reply if this ever gets on YouTube and tries to reinstall my faith in the old thinking, because I have some new thinking. And don't mind me, I am looking for the blue. Maybe I have it here. I guess I can use green, but in the book I talk about a blue balloon. I think I talk about a blue balloon. We're going to talk about green, about the green balloon. Okay, you're all familiar with this. You have a balloon in a cold room, a green balloon. And it's cold, and it's deflated, and it's small. You bring it inside. That balloon now gets very big. The current philosophy is the particles, because of the temperature of the room, are now moving faster and faster. They're hitting the edges of the balloon and they're pushing out the balloon. And my question to myself and to the community, and here I just may be so removed from current physics, but I am trying to back CIG theory into an explanation of this. I have the small balloon. The small balloon. It has a volume, say, of 1. I now have a big balloon with a volume of, say, 6. We have all seen this. And my question is, where did the space come from? We have to agree on the definition of space, and there is more space, more volume here than there is here. So where did this volume come from? The current philosophy is the little particles are moving faster. But to me, when the particles move faster, this particle might move fast and be here, and this particle might move fast and be here, and this particle might move fast and be here. But where did the space come from? I still can't figure this out unless I apply CIG theory and say that the motion here, which is greater here, turns it into greater space. So that's my solution to the volumetric changes from a cold balloon to a hot balloon. Might be wrong, but it was a thought that I thought worthy enough of writing down. So now we're going to talk finally, and I may have missed a couple topics. I took the topics off of my posters, which I may hold up at the end as a conclusion. Maybe you can extrapolate something out of them. They're rather haphazard. I probably didn't cover everything, so maybe a quick snapshot of this will help you understand this better. or delve into another topic that wasn't there before. So we're going to discuss E equals mc squared. We all know this equation. We know the equation. We'll put it in red. Energy equals mc squared. So I'm going to back this equation, E equals mc squared, into MTS. And just how are we going to do that? We're going to try to find a little empty space. We'll do it right here. Get rid of the balloon and some other things. What I'm saying in E equals mc squared is that it's another variation of MTS. It's not how I came up with the MTS equation, but I backed into E equals mc squared at a later date. We're not going to go over the history right now of CIG theory, how I got here, what my thoughts were. But we are going to discuss E equals mc squared. We all know nuclear bombs. And we know that the blast from a nuclear bomb blows down all the houses and everything else. Very sad story. That's the energy. And that equals mc squared. Mass. The speed of light squared. What MTS says is that energy is not a fundamental. Energy is transitional. This is space. And the new volumes of space displace the existing volumes of space and blow the houses down. That's the energy as interpreted by CIG theory. It's the new volumes of space that displaces the existing volumes and everything gets knocked down. M is simply the M in MTS. And if you recall, T was forward reverse vector time, or 0 miles per hour to C. So I have 0 to C going this way. That's 1 C. And then I have C back to 0 going the other way. That's the other C, or C squared. So what we have here is an interpretation that within E equals mc squared, the MTS equation reinvents E equals mc squared by taking energy, which is transitional, turning it into a fundamental. It retains C squared, forward reverse vector time, and it keeps mass. Now the theory does contemplate all the permutations and possibilities of the environment that we see. We have all the spatial extents, all the possibilities of matter and everything in between. We're going to discuss dark matter, dark energy in part 2. We're almost there. But basically, what we have in MTS is every possible volume, every possible density of matter, and every possible element of motion. We have 0 to C. We have all the volumes possible on this side. We have the standard model here, somewhere in between. we have black holes on this side, and in one equation, we contemplate all the fundamentals. I'm going to look at my note briefly here, see what I forgot. If it's too convoluted, it'll take too much time, so I just want to put up the wave function, something else for you to study if you're so inclined. And I believe it's the Greek letter psi, and that's the wave function, and that's where all the confusion is. Hopefully CIG theory resolves some of it. Thank you. Stay for part 2. Have a good day.